This is part 3 of observation 3, the observation on Mercury. You should return your system back to sunset on whatever day that you have found. This is February 2013 when I did this, and it just turns out that on February 2013 that Mercury is at its greatest elongation for when it's an evening star, where it's very, very close to greatest elongation, which makes it easy. Makes it a little bit easier for us. Part 3, what we're going to do is we're actually going to fly to Mercury, and we're going to use the techniques that the simulator has. So we'll scroll over Mercury, right-click, and select Go There, and it takes us there. Now you can speed this up by just hitting the space bar, and it'll get you there right away. Well, it will take us basically to orbit around Mercury. We want to actually go down onto the surface, so right-click on the planet and then say Go There, and it'll tell you that you're going to what latitude and longitude you're going to be on. So we'll go down onto Mercury. Alright. Now what we're going to do here is we're going to measure the length of the solar day, and we're going to compare that to the information that you got from the info side pane on the sidereal day length, and we're going to you're going to calculate a difference, a percent difference between them. And so basically you take the difference between them and then you divide by the sidereal day length. And then finally we're going to go to the favorites and calculate or measure the length of a year, one revolution of Mercury around the Sun. Okay, so it's pretty easy. The hardest part, I think, of this particular part is locating the Sun. So if we go to sunset and then look west, somewhere around here we should be able to find the Sun. Well, it looks to me like, oh, this is January. Well, let's go now and try that again. Sunset. Well, it takes us way into the future, and that's not going to work for me, I don't think. So like I said, the hardest part of this is locating the Sun. Instead of doing that, because my simulator takes us way into the future, I am going to go to sunrise. Well, first of all, I'm just going to scan it. I'm going to, well, let's find the Sun. Let's do that. Let's find the Sun. So we find the Sun. We click on the Sun, and it says, Sun is not currently visible from your location. Do you want to hide the horizon before centering? And I'm going to say no. It is currently 20 degrees below the horizon. Okay, so it's below the horizon, and I'm going to just kind of scan things, see if I can find it. So I'll use the hand, and it's called the adaptive hand. With the adaptive hand, you right-click, grab, and rotate. This here is Earth. We'll look east. I don't see it anywhere so far. It's not west. Oh, there it is. So here's the Sun right here. Now if that doesn't work, you basically, the easiest way to do it is just look east, and then we could try for sunrise, but I'm afraid that if we try for sunrise, it's going to take us way in the future again. So go back to now, and I'm not sure why it does that, but my simulator does that. Sometimes you have little quirks that pop up. Okay, so here's the Sun. So if I use the day mode and then let it run, whoa, that went fast. How about we use the hour mode and back it up. And hopefully we will. There it is. It's coming back. All right, so there's our sun. Now that is the hardest thing to find in this part of the simulation. Where's the sun? Once you locate it, then you can manipulate it. We've got it selected, and we can center it to keep our eyes on it so it doesn't move out of our sight. Now they say, okay, you go from sunrise to sunrise. You could take the date and time, so it's March 23rd, 2013 at 13:06, right? We could take the date or time, and then we could let the simulation run until the sun rises again. But then they give you a footnote and it says, but to be more accurate, what you can do is you can basically look south, go south, turn on the local coordinate system so that we have a local meridian, right? This will be our local meridian, and then since we have the sun is visible, let's go ahead and start it up here, and let's bring the sun over to basically noon on Mercury. Okay, it'll be the highest point in the sky, and we'll kind of click it in until we've got a pretty good, there we go. One more and it'll be there. Okay. Okay, so now if we take, the time is 12:06 on April 13th, 2013. All right, and then the next thing it tells us to do is to use select time speed of 1 day, and we saw how fast it moved, but that's what they tell us to do, so we'll go ahead and do it. Write that down, 12:06, April 13. And then we'll let it run, and we'll just sit here and watch. Uh-oh. And then we'll have to come back. Okay, there's the sun. Okay, so now if you want to take a little bit more time, you can use hours. That slows the process down a little bit. And if we use hours, we can see here, and in the very last bit we can get a good measurement right there. So the footnote tells us that if we use the local meridian and noon, that we can get a more accurate measurement of the length of a solar day on Mercury. Write that down. It's 10:06 October 6th, and you would have to then calculate the difference in days and hours between those two dates to determine the solar day on Mercury. And so that's that first part in part 3. The second part in part 3, it's just a calculation. It's a simple calculation, and you use the information from part 1, the length of a sidereal day, and you can use the information also from part 1 for the length of the solar day, and you can make that calculation, and you calculate the percent difference between the two of them. Now, the last part of this observation is for us to measure the length of one orbit, or a Mercury year. And for that, we have to go to the favorites, scroll down to Solar System, Inner Planets, Inner Solar System, click on that, and it will return us to the view where we get to see Mars, Earth, Venus, and Mercury, the inner planets in the inner solar system. And what you're going to want to do is you are going to want to, let's go to now, just because. And you're going to want to enable the first of all, from here, take a time reading, and you want to watch Mercury as it makes one complete orbit around the sun. And if you might want to play with this a little bit. If we use hours, so if we back this up, get a good position where you like it, either maybe right from here, right to left, or top to bottom. I think that's a good position right there. And then what you do is you let it play out by starting the runtime forward, and then you first of all make sure that you get the time and date. And I think 1 hour, I think if you use the hour, that's good. If you use a day, it's just way too fast. And we have a comet here that's going on this year. All right, so Mercury is halfway done with its orbit. And Mercury is nearly done with its orbit, right about there. Oops, right about there. Maybe back it up a little bit. Okay, so then you have you take the time and the date, and you calculate how long it took for Mercury to go around the sun, and that will give you the orbital period of Mercury. Now, sometimes these simulators in the favorites portion of the program don't work. You may need to update your system. Click Help. If it needs updating, there should be an update there. Well, or you can go to Live Sky and check the program for updates. Sometimes it's in Help, and sometimes it's in the Live Sky. If it's in Live Sky, click on Check the Program for Updates, and then make sure that your system has this favorites here. Sometimes you need to update the program before you get this capability. Okay, if you have any questions, let me know.